Hello, computer security class. For my individual project, we're going to be covering Cryptolocker. So Cryptolocker, a study. Here we go. So here's an overview. We're going to start with a summary of Cryptolocker, an overview of the lab environment that I'll be using. Then we'll get into some demonstrations. I'll talk about my personal experiences with Cryptolocker. Then we'll cover some takeaways. All right, so here's a summary of Cryptolocker. It was active in the years 2013 to 2014. It had several different variations. I have personal experience with what is called Cryptolocker 2.0. It exploits the fact that individual users can encrypt files in Windows if you have the right access level. Individual standard users can encrypt files. Then the malware takes measures to destroy backup data that can range from restore points to volume shadow copy. So just the amount that's been extorted is at $3 million estimated, but it's really hard to estimate how much money it's cost businesses. It's definitely billions of dollars, in addition to how much is actually extorted. But in amount of files that have been lost, the amount of time to recover that data, it's in the billions of dollars. Huge impact. So we're going to cover how Cryptolocker operates. So generally files are delivered through an email attachment, and it uses the fact that by default Windows hides file extensions. So an attachment, if it has a double extension, if it was a file .pdf.exe in Windows, it might just look like .pdf. So people open it expecting to open up a PDF file or actually executing an exe file. And then once it's active, it signals the malware's host server, wherever that is. And then the server generates an RSA key pair and then sends the public key back to the PC. Then it attempts to asymmetrically encrypt all of the files of a certain file type. Usually these are just documents. I could name them all: docx, PDFs, text files, really some of the most important files that people use on hard drives. And so then, it encrypts those with that public key. And then those files, once encrypted, can only be decrypted with a private key, which in this case the end user does not have. Additionally, it attempts to take measures to prevent anyone from easily restoring the files. Like I said earlier, that's deleting all volume shadow copy instances and any kind of backups that end user has access to, restore points, etc. And it's critical to understand that this malware can only operate under the context of the user who was infected. Alright, here's an overview of the lab environment. For this lab, I've decided to use just a Hyper-V server. It's free, it's quick to set up, and I just use VMs so I can use checkpoints. So when I was testing this out, I could break them and then roll them back to a previous checkpoint. I also have an admin laptop, and I created a domain for this. So I have a domain controller and just one Windows 7 virtual machine. And like I said, I had a domain controller. I created a domain for this project, but I don't really think it's needed. So then I have two accounts. There's an admin account, which is called khadmin, and another account, which is just a standard user account. And also there's a network file share. Here's an overview of the demo. So unfortunately, I decided to not really use Cryptolocker. I didn't want to risk actually infecting myself while doing this demonstration. So we'll just be simulating what it does using scripts. The first part is try to seek and destroy all files that I have access to, the logged in user has access to. The next part is to delete all shadow copies. That'll demonstrate destroying all backups. All right, before we get started with the demonstration, I just kind of want to show you my lab a little bit. Recording this on a MacBook Pro, but I use the Microsoft Remote Desktop product to route our RDP into the virtual machine that we'll be using. So I don't know if you've used this before. So I've created two different login desktops here. One is logging in as the admin user that I mentioned, and the other is a standard user. This is just a way to quickly connect. So just double clicking on it should launch this window. And now we're logging into the good old Windows 7 desktop. If you see the black background here, just that tells us it's the admin user's desktop, and the standard blue desktop is the standard user's. I'll just show you this environment for a second before we get started. Got a couple different mounted hard drives. The one that we'll be focusing on for our demos is the F drive. So go to properties here, we can see previous versions. So this computer's been set up to create volume shadow copy backups, and I created one moments ago. I don't know if you're familiar with this, but this allows you to play back time to see what this looked like for this example 15 hours ago. So you can open up these files and interact with them. I also have a network share. It's on my vhost. I'm just using that to store my scripts for this. I like to do that outside of the VM just so they don't accidentally get rolled back or deleted during this project. Alright, so we have some different files here on the F drive. I'm logged in as the admin user, so I can get into these admin files and the public files. Really, they're just empty files, test data. And in the admin file area, we got some private data. And I've used access control on the admin files. For example, on this F drive admin files folder, I've set up an admin group, and only it has access to these files. And then the public files just have standard permissions. I didn't really change anything, so everybody has access to it, as you'll see here. All right. So we'll just back out of here real quick. And then we'll log in as the standard user. All right, I had a session open apparently. So we'll get into that same F drive. If I try to get into the admin area, I'm getting prompted that I don't have permissions to this folder. But it does have access to the public location. I can still get to previous versions, and then I can, even in the previous versions, I still can't get access to these admin files. I can still get access to the public. Oh, you can see here is before I even created a bunch of extra files. And then the scripts will be using PowerShell, the integrated scripting environment. What I'll do is I just mapped a network drive like I said, and then I have a scripts folder. And then we have some of the scripts that we'll be using to demonstrate this lab. All right, now we're going to do the demonstrations. The first demonstration is going to be as if we were an admin user who was using a computer that got impacted by Cryptolocker, just to show what some of the damage can be. I'm going to remote into the Windows 7 VM. And here we are. So if you'll notice, I said we're going to be targeting the F drive. The F drive has previous versions. We can open those up. You can see previous files, what they look like. And get into the admin area. Guess we can delete that. Don't need that. Yeah, like I said, we had previous versions. We can get into the files that are there. And here we go. Now I have a PowerShell script that I wrote that I call Cryptolocker Simulator. Make the font a little bigger. Come on. There we go. So what I'm going to do is simulate like you got Cryptolocker. It's going to target the F drive. It's going to encrypt files. And it's going to do some renaming of them. And then it's going to try to delete all the shadow copies that exist. Here we go. Found 32 files. Really important stuff. Admin files are on the list of things that are impacted. Attempting to delete all your shadow copies as well. The message I have displayed. All right, looks like it's done. It's about the time you start to panic. So we'll take a look at the F drive, public files. Notice the colors of the file names have all turned green. That means that they're encrypted. Additionally, if I try to look at the F drive, I'm going to look at previous versions, and there are no previous versions, unfortunately. So if you didn't have good backups, you'd be stuck right now, possibly paying the ransom to get a code and the key to unlock your files, and now you're having to go to backups. But if you're depending on your shadow copies to do the restores, they're gone right now. And additionally, admin files, greened, pwned, really important stuff. I didn't have actually make it so you can't open it. It's just a simulation of what can happen. So you're looking at all your files. You're freaking out right now. Life is not good. All right, that completes that demo. Okay, the next lab is going to be a more secure environment that gets impacted. So we're logging into the Windows 7 VM as a standard user. Here we go. I have to mention I did checkpoint, I restored to checkpoint, so all the files that were deleted or, impacted, encrypted, all that stuff are back now, thankfully. I'll just verify that. The previous versions are here. I can still get to them, so everything's good. I know you're worried. All right. What are we doing? Oh, yeah. So, oh yeah, I need to delete that. So here we are logged in as a standard user. Cannot physically get to these admin files. I can get to these public files. There's a public folder, all that good stuff. All right, so we're using the computer as a standard user, and then we're going to use a simulator that will simulate that, hey, I was in my email and I opened up an attachment and here's what happened. All right, so found 16 files this time, which is less. I don't notice any of those important files and things like that. We see an error now. It says did not delete the shadow copies with the following error, initialization failure. So let's take a look. F drive, admin files, can't get to those still. Public files, well, these ones are messed up. What the heck? So things were still impacted. The files that this user had access to were still encrypted. The file name was changed. But if we take a look at the previous versions were not deleted. Volume shadow copy was not impacted, although it was attempted to, and as you saw in the previous demo, it did work when it had the proper privileges. So the repair process, if so needed, would be very simple. You would just open up the previous version the volume shadow copy, and you could just restore those files right in. So I'll do that now. And here we are. Now we have original files back just by using this volume shadow copy. In our case, it was 3 hours back. We were able to go back and selectively restore those files. Okay, that completes this demo. Alright, just to recap a little bit on the labs, or the demos I should say. Demo 1 was when things go bad. As you saw, the targeted files were encrypted. The backups were deleted in this case, the volume shadow copies. So now you're talking options when this happens. Not in a good place. You have the option to restore from backup on another media, or paying the ransom. The second demo is when things are configured a little better. Just the files the users had access to are deleted. I should say encrypted, I never said deleted. And the backups are not impacted. All right, so now I'd like to talk about my experience of this situation. I chose this topic because while it is, a good number of years old, it's been a while since this happened. It reminds me of good security practices that I still use today. And it really taught me a life lesson. So I'd like to just talk about my experience when I encountered this. So it was spring 2014. I was working at an organization as a network administrator. And in this case, it was delivered through a compromised Yahoo ad provider. Not exactly sure if the end user clicked on something to install something on their computer. Some research told me that it just launched automatically through an ad that this person saw. They were checking their Yahoo mail. It was on the 0 day. It was corrected very quickly, but we were still impacted. So I was notified by the end user that their files looked funny and wouldn't open. Kind of a weird help desk call to get. And I wasn't alarmed immediately about it, but I still checked it out right away. And then they sent me, shortly after they sent me the screen capture of the ransom screen. So I was definitely highly interested, and put down anything else I was working on at that exact moment and headed down to their computer. Yeah, so you get that feeling when something like that happens. You're like, oh God, here we go. So then I investigated it, immediately disconnected the PC from the network. I think I'd heard about Cryptolocker, and so I knew ransomware is what they were about. So the first thing I did was just disconnect it from the network. So if it's actively doing any damage, you want to make sure it's stopped. So I think the next thing I did was remove the malware from the PC. I wrote this. But I think the first thing I actually did was take a look around the enterprise for signs of activity. Then I downloaded a patch to remove this malware. It wasn't very difficult in this case. It just gets in, does its job, and it's not too hard to remove, but the damage is already done. So its goal is not to be hard to remove, nor does it really spread from one computer to another. Its job is to just sneak in like a Trojan and just do its damage, and then there you go. Right, I put that twice because I'm supposed to put that in the last spot there. All right, so it was not a good day. So after investigating this a little bit further, so 100 files on this person's PC and over 9,000 files on the network were encrypted. So not very happy at that moment when I found out that had happened. The end user did not have administrative privileges at all with that account. So it could have been a lot worse. So no local or network backups or shadow copies were deleted. One of the first things I checked. So the repair procedures. So yeah, when something like this happens, your primary focus is just to make sure that there's nothing actively happening. So there's a lot of scanning and rescanning to see if there's anything that was changed. But it was very easy to detect which files were encrypted. They had a very specific signature to them. Might have been a flag, something that you can look up with a script and it'll tell you if it was encrypted, or it might have been the date created. It was exactly the exact same moment. Just set it to some random date, but it was the same for every file. So it was not hard to find every file that was encrypted just by looking at that date. So it was like the second demo. It was not successful at deleting the volume shadow copy, and we did use that on our file servers. It happened like 3 times a day where it takes a volume shadow copy snapshot, and it had occurred not too long prior to when this happened, and there was a definite moment at which this occurred, and we knew about it. We knew when this had started, so we knew that if we went to that volume shadow copy version of the files, that we would get the files prior to being impacted. So what I did was I wrote a PowerShell script that detected all the files that were encrypted, and then it went file by file and replaced them with the volume shadow copy version, and to all 9,000 files. And then I wrote some tasks to keep rescanning the network to see if anything like this was going on. But fortunately, it was just that one computer. No other computers were impacted in this case. And once we cleaned things up and fixed all the files locally on the person's laptop and over the network, it did not occur again. And we did employ antivirus and malware scans all the time. We just got bad luck. On this one, it was a 0 day. All right, the impact after the dust settled. So there's, you go through emotional phases when something like this happens, and then hopefully, you still have a job is what you kind of think about. You're like, what the heck happened here? Why did this happen to us? And what's going on here? Especially if you're, the one accountable for something like this. But the impact after the dust settled, there was downtime when the certain files were unavailable. So these files that were encrypted were public to other people in this person's department. So I should mention this. Yes, the files that were impacted on the network were files that many people uses. There were many files that this user had the ability to modify across the network. Like I said, it was about 9,000, and every single one of those were encrypted. So from the time when this happened until the repair occurred, anybody who needed to use these files, they just couldn't get to them. They were unavailable. They would get the same messages like it's encrypted. So that was part of the impact. So thankfully, we used a role-based access control to really target what files people could use and what their file permissions are. So we actually, I just had gone through in the past maybe 6 months with department leads, department heads, to figure out the minimal amount of security required for different areas on the network. For example, somebody from one department needs access to another department's files, but really they don't need to modify them. They need read rights. So that was an exercise we just went through and made a bunch of changes. Whereas in some cases, people have full permissions. Hey, they need access, you grant them full permissions. In this case, this user had the ability to modify 9,000 files. But had we not gone through this exercise prior to, they may have been able to modify many more files, and the impact would have been greater. So here, I'm guessing it's about 20% of the network files. And you should look up role-based access control. It's a good practice. Any file changes that were made between right, this is part of the impact. Any file changes that were made between the last shadow copy and the time of impact were lost. So if, let's just say, the shadow copy on the server occurred at 9 a.m. and at 10 a.m. is when they were encrypted, any changes between 9 and 10 were lost. So really the bottom line was, there's a lot of communication with company leadership, and we found that there was no business impact, thankfully. There were just possibly some minor changes that were lost, and everybody was fully aware of this. So there was really it comes down to money. Maybe some time was lost while people couldn't access these files, but since we were so quick on getting this restored, there was no business impact at all. Many businesses have way worse stories that they tell than what happened here. So we're very fortunate because we're properly prepared, I think. All right, wrapping this up, some takeaways that I think you should have, at least from my lessons, I'm hoping you have, is thou shalt not log in as an admin for non-admin functions. This applies everywhere. It's just a bad security practice to be logging in as a user who has admin privileges. As you saw in demo number 1, bad things can happen. The next lesson is target your file access. In this case, we use role-based access control and give as little access as needed. And in my rules that I follow, if I have control of it, is our admin should always have 2 accounts. So if you're a person who's an administrator or network administrator, you should have 2 accounts. One is your standard operating system use that doesn't have privileges, it's just a standard user, and then you have one for administration. And in Microsoft, Windows, or server case, you need to do something as an admin. You escalate the task that you're doing to the admin level, perform that task, and then you're back down to the standard user level. All right, I hope you enjoyed this and maybe take away some things. I tried to keep it simple. I could have got a lot more complicated with this, but I just really wanted to illustrate some points and best practices and my experiences. Got some references here that I used for this project, Kaspersky regarding Cryptolocker, and Wikipedia. All right, well, I've enjoyed this, and thanks a lot. Thank you.